Our first chapter in Functions class is titled P, Prerequisites. In this chapter, we'll review content from Algebra 2 that will help guide us in our functions content. Lesson P2 is titled Exponents. In this lesson, we'll simplify expressions using properties of exponents, and then we have a change for our second objective. Instead of modeling scientific notation, we're going to model radicals and rational exponents. But first, let's start with properties of exponents. There are 8 commonly used properties that are reviewed from Algebra 2. In the first property, when you multiply bases, you can combine or condense their exponents through addition. Conversely, if you divide bases that are the same, you would subtract their exponents to simplify. Property 3 is when you have a negative exponent, you take the entire base and find its reciprocal, putting it in the denominator. That makes the exponent positive. 4 is an easy one. Anything that has an exponent of 0 equals 1. 5 is kind of like a distributive property. If you have 2 parts of your base or in your base with the same exponent, you can distribute the exponent to both of them. 6 is a power of a power property, kind of like a superpower. If you have a base already with an exponent, and then you're raising it to another exponent, you simply multiply them. 7 is kind of like 5. It's like that distributive property again. If you have a quotient of bases, you can distribute that exponent to the top and the bottom. And the last one is probably the least commonly used property of exponents. If you have an absolute value of something with an even exponent, it just equals that exponent. The absolute value would go away. For each example below, we're asked to evaluate the expression. Use only positive exponents when necessary, so we won't have any negative exponents in our final answer. Our first example and our second example actually look similar, but there's a key difference with that parenthesis. In that first example, negative 5 squared means you're squaring the negative and the 5. You're squaring both of them. So that's the same as negative 5 times itself. And anytime you multiply 2 negatives, they would make a positive, and that just gives you 25. The key difference in that second example is now the negative doesn't have the parenthesis. And in this case, you're only squaring the 5. You're not squaring the negative as well. That means the negative stays in the answer, and 5 squared is 25. Watch if that negative is in parentheses or not. The next example, 2 times 2 to the 4th. That first base of 2, since it doesn't have an exponent written, defaults to an exponent of 1. And since we're multiplying like bases with that star in the middle, that means we simply add our exponents together. And 1 plus 4 is 5. So that's just 2 to the 5th, or 32. As we keep going, 4 to the 4th divided by 4 to the 6th, with that division, we're now going to subtract our exponents. 4 minus 6 gives us a negative exponent. That would be 4 to the negative 2 power. We have that negative exponent rule. To make it positive, we'll take the reciprocal of 4, which means 1 over 4, and that allows us to square that exponent, or that base, and that would give us 1/16. See if you can try the next one. We have numbers and variables. Pause the video and apply the properties to evaluate that expression. Then press play and see how you did. The 3 and the negative 3 and the 4 would multiply to get negative 12. A times A would be A squared. And if we have B to the 4th times B to the negative 3rd, and we add those exponents together, we would get B to the 1st, or B. In the next example, again, that parenthesis is going to be significant in our solving process. We have that 3a on the outside, but then we have negative 4a squared, 2 bases, but to the property of 0. No matter what that inside is, if it's in parentheses to the 0 power, the whole thing equals 1. So if we take 3a times 1, our answer is simply 3a. The parts on the outside of that parenthesis do not get that exponent of 0. Keep going, we just have a couple left. Or x divided by 10 to the negative 1. Again, we've got that negative exponent. So if we want to put the base in the denominator, but it's already the fraction, we're just going to flip the fraction or take the reciprocal. Instead of x over 10, we can make that 10 over x if we flip the whole thing. And that makes negative 1 become positive 1. And that just gives us 10 over x. Now we have one more. Again, see if you can try this one on your own, and then press play to see how you did. For this example, I started with the numbers as the coefficients, 3 over 15. I simply reduced that down to 1/5. And then since the a's were being divided, I subtracted the exponents. Negative 3 on top and 1 on the bottom. Negative 3 minus 1 is negative 4. For the b's, I did the same thing, but watch this. If it's 4 on top and negative 1 on the bottom, 4 minus negative 1 actually becomes 4 plus 1, which was 5. We started off with 1a to the negative 4th, b to the 5th over 5, and then I put that a to the negative 4th in the denominator, making the exponent positive. And there's simplifying using those properties of exponents to condense each or evaluate each expression completely. Let's take a look at our second objective, dealing with rational exponents. Rational is just another word for fraction. If you have a base with a fraction exponent like a to the m over n, that is going to involve a radical. And a radical is just a square root symbol. Now the key for this is that the m stays the power of your radical, and the n is what creates that root value. If you want to rewrite that in radical form, or just to see how you'd evaluate it, you keep your base of a on the inside, but then n goes in that corner. That's the root you're taking. And you raise that entire amount to the m power. So then conversely, if you had something like that, n a to the m, and you wanted to write that as a rational exponent, keep your base of a, m would go in the numerator, and whatever that root value is goes in the denominator. You just write it in that opposite order. And we just have a few examples on how to convert. Change from radical to exponential form. So in this set of examples, we start with that radical form, and we'll have an exponent when we're done. The square root of 3. If we think about figuring out what m and n equal, if nothing's written in that corner, the square root means the root is 2. And like before, if there's no exponent, that means the exponent defaults to 1. To write this as an exponential, that means we just want that fraction. Our base is going to stay 3. The numerator is the power for the fractional function, that's a 1. And the base is the root, which is 2. And that's all you do, 3 to the 1/2 power. In our second example, same idea, but now we have 3xy as our base. And that means 3xy will be our base in exponential form. Notice that 5 is on the inside, that's still your m value. If everything in the parenthesis has that exponent, that stays m. Our n value on the outside is going to be 2 again because it's a square root. To write that then as exponential form, it's going to be m over n or 5 over 2. Try the next one. Cubed root of 27. 27 is our number base. We're going to keep that on the inside. 3 would be our n value, but there's no power. That means it defaults to 1. 27 to the 1/3. That's writing it in exponential form. We can also evaluate this. 27 is a perfect cube. Think of a number you'd multiply by itself 3 times. 3 times 3 times 3 is actually 27. So we can rewrite it in exponential form, and we can also simplify. Now, the last one is the trickiest one of them all. We knew we had to have one challenging one in here. We have something that's on the outside of the radical and something that's on the inside. And we want to rewrite this and always keep our answers simplified. The 2x, we're just going to leave this for now. So I'm just going to leave 2x on the outside. And then we're going to work with that radical symbol. 4th root of x to the 3rd. The 4 would be the n. The 3 would be the m. So that's kind of similar to what we were doing before. Nothing tricky there. That would be 3 over 4. But now we have two bases that are the same. X times x to the 3/4. Technically, that first x has an exponent of 1. And when we multiply our bases to combine our exponents, we add. So this would be x to the 1 plus 3/4. And I'm just going to give that a common denominator. 1 could go into 4, so that would be 4/4 plus 3/4. So I guess that really wasn't so bad. 4 plus 3 would be 7. And that would simplify that rational exponent to 7/4. However, we can't forget about that coefficient of 2 out in front. That's changing from radical to exponential. Flip it over and we'll change back to radical from exponential. Let's finish lesson P2 by changing from exponential back to radical. In our first example, we have x minus 7 in parentheses. So this entire part is our base. Notice, however, we have a negative exponent. The first thing we're going to do is fix that. We always want our exponents to be positive before we convert. That means we simply take the reciprocal of our base. And then that changes our exponent to positive 1/2. Now remember, the 1 is our m, the 2 is our n. That means we're taking the square root. And when we take the square root, the 2 is optional to write in that corner. If nothing's written there, it just defaults to 2. So you don't have to write that in when it's just 2. And then because m is 1, we also don't need to put the 1 as our power. So that would be your final answer. 1 divided by the square root of x minus 7. In our next example, we have x squared on the inside to the 2/5 on the outside. When you have an exponent on the inside and the outside, we multiply. That's one of our properties. That means it's x squared times 2/5, which technically means 2 over 1 for that first part. And if we multiply straight across, that's x to the 4/5. We've simplified our exponent. Now let's convert it to radical form. X is our base, so that goes on the inside. 5 is the denominator, that's our n value, that's our root. N is our root, yes, but n equals 5, sorry. We'll put 5 as our root. M is 4, and that's our power. That means we raise the whole thing to the 4th power. And just like that, we're done. All right, everybody, one more. X to the 0.75. Well, if it's a decimal, we need to convert that back to a fraction. 0.75 would be 75 hundredths, or 75 out of 100, and that reduces to 3/4. That would be equivalent. Once we know our exponent, now it's kind of business as usual. Our base is x, and that stays on the inside. 4 is our n value, and 3 is our m value. And there you go. Those are your notes for lesson P2. Make sure to take the P2 quiz and then submit your notes for your assignment.